Great. Hello, guys. We're excited to be hosting this today's session, and today is really going to be very exciting. And so we're just going to take like 1 or 2 minutes to let more people in, and then we're going to kick off. If you are joining in, please kindly tell us the location you're joining in from. We'd like to know. We know we have practitioners that are spread across the US and Canada. It would be really nice to know the city that you're in today. We'll just wait for another 1 or 2 minutes and then we will kick it off. Oh, Carol, I see you. Toronto, Team Toronto. It's good. Virginia. Oh, Minnesota. Wonderful. Wow, Minnesota is leading the pack. It's two practitioners from Minnesota. Exciting. Okay. Yeah, thank you guys for joining in. Today I will be, listening a lot, like 95% of the time for me as well. Just not being the person who's talking about the test, but who's listening in. I would like to, for those of you who don't know me, I'll just quickly introduce myself. I'm my co-founder, Linta, and then we'll pass it on to today's guest, Daniel Chege, who is a fellow practitioner as you guys. I'm Dr. Chidozie Ojobor. I have my training in microbiology and a PhD in molecular genetics. We started this company, my co-founder and I, Linta, who is also on the call. Linta, do you want to say hi? Okay. So Linta and I started this company a few years ago because we saw a gap in the testing space. We did see that there's tons of things that we can actually incorporate into clinical practice from the microbiome, science, but we just didn't have a lot of tools that could actually do those in actionable ways. And so our goal was to create a comprehensive, actionable, and accessible test. And for a lot of you who have been using the test, we've got a lot of feedback. We know that you're finding them really, really helpful. And then apart from the fact that the test is just helping you understand your patient profile more, a lot of you are also learning more about the microbiome science. So that's really, really exciting. But today we want to, get a practitioner insight into the test. How does a fellow practitioner like you use this test? And so this is going to be a very, very practical experience. And we are also recording this. So this will also still go on Vitract University when we're done. So you can always still go back and catch up with it because I know there's going to be a lot of questions that you guys have. So I have the pleasure to introduce Daniel Chege. Daniel is one of our practitioners using the test, and he's an incredibly brilliant guy. And I have had several conversations and meetings with him, and I just love the way he thinks about the science, especially how he thinks about it translationally, and because it goes beyond just the science. It's like how do we incorporate that science into clinical practice? And so, without further ado, Daniel, you're welcome. Please do introduce yourself, and then you have the stage.
Oh, awesome. Thank you, Dr. Ojobor. My name is Daniel Chege. I'm a nurse practitioner. I am also certified in functional medicine. So I'm certified through the Institute of Functional Medicine. So a lot of what I'm going to be talking about, especially if you've gone through the Institute of Functional Medicine, you will relate with it. It's going to be familiar material. I have been practicing functional medicine for about 8 years now, and I love what I do. And I am really excited about this test because it's filling a gap for me that I've been looking for a long time. Especially when you're doing root cause medicine, it usually tends to, you can go deep and deep, but sometimes you don't get the answers that you need to get to that root cause. And this test gave me that. So it's been really good to use it. So I can go ahead and dive in, right? Okay, good. So we'll talk about gut health in general first, and what we really look at when it comes to gut health, and then we can see how we can apply the DeepGut test. And I'm going to talk about the DeepGut test more than I'm talking about the gut scan test, because there's two tests here. how we will apply that and how it compares to what we already do and what gap it's filling for us. So when we talk about gut health, we're looking mostly at 5 things. And those 5 things, I like to put them in an acronym called DIGIN. So DIGIN. Digestion, intestinal permeability, gut microbiome, inflammation, and the nervous system. And those 5 are, whenever you are checking the gut, those 5 are the major things that you're looking into. So when somebody says they have gut issues, you want to classify which one of those 5, if not all 5, or if some of those 5 that they are going through. And that is going to help you as a practitioner to be able to hone in to exactly what you're dealing with and how you can be able to treat it. So when we talk about digestion, pretty basic. It's how you break down your food so you can be able to get nutrients for your body. So the gut usually does play a role in that, and that role is kind of twofold, where you are using a lot of enzymic activity, like from the pancreas, from your gallbladder with bile, but also the microbiome plays a role into making sure that you're creating an environment where you're digesting food properly. And then 2 is the intestinal permeability, or what we call casually leaky gut. And this is where the gut barrier is broken down, and or the integrity of the gut lining. So you want to keep that intact. So that usually ends up causing issues later. And of course, it ends up feeding into other things like digestion again, or the other 3 that we're going to talk about. The third one being the gut microbiome. That one is what we are probably going to center on mostly whenever we're talking about deep gut. So in this particular case, where the gut microbiome will actually be our quarterback and to show us more about what's going on with the other 4. Okay. And then the 4th one would be inflammation. And inflammation, in our case, as practitioners, we're looking at diseases like ulcerative colitis, inflammatory bowel disease, or Crohn's disease. Those ones which usually cause a lot of things like just a lot of inflammation in your gut lining, which can usually be caused by immune response. And that immune response, again, is usually caused by mostly an integrity loss in the permeability of your gut. Okay, so I'm kind of putting that intentionally in there so you can see how all of these relate. And then the 5th one is the nervous system. So how you create neurotransmitters would be more specific. That's a gut-brain axis. So a lot of the neurotransmitters, most of the neurotransmitters are usually made in your gut. So if you're not making enough neurotransmitters, it's inevitably going to affect your brain. So things like anxiety, depression, ADHD, OCD, the things that we usually say are brain issues, most of the time they usually are stemming from your gut. Okay, so with what we are armed with right now, how can we be able to treat those 5 categories? Okay, so right now, I've been using a few tests prior to me starting to using DeepGut, which usually give me a really good idea as to how I can be able to treat this 5, but it's not giving me the complete picture, especially when it comes to the microbiome. So I'll give you an example. Most of the time, whenever I do a comprehensive stool test, I will get probably a page, maybe a page and a half of like the microbes that have been checked. And most of the time, it's usually being checked by a process called PCR, and Dr. Ojobor can go much into deep detail on that one. But there are not a lot of microbes. So it's not giving me a big picture. It's like you have this bus which can carry 100 people, but you're only being shown the face of like 10. And the other 90, you are just not seeing. You don't know exactly what their makeup is. You don't know if they're male or female. You don't know exactly anything about them, right? So you have a limited amount of knowledge to just treat with the 10 that you're seeing. And then on top of that, then we get test results like things like calprotectin, which usually shows you inflammation. Something like it checks something like butyrate, which checks butyrate levels, and then things like secretory IgA, which tells you the immune response in your gut lining. eosinophilic activation protein, which tells you if there's any activation of histamine in your gut lining. All these are usually end products of what the microbes are doing. So are they informative? Yes. So if, for example, if butyrate comes back low, then what I'm going to do is I'm going to give them butyrate, right? And the butyrate is definitely going to help because they are low in butyrate. Or if the eosinophilic activation protein is high, then I know that they're producing a lot of histamine. So I would give them something to reduce the histamine activation in their gut. Well and good. The problem that I run into with these tests is that it's not telling me what the root cause is. And the root cause in this particular situation would be, for example, if butyrate is low, then it is a microbe or multiple microbes, which usually tend to produce a lot of butyrate in the gut that are not being fed, or we don't have enough of that. And because we don't have enough of that, then butyrate is not going to be produced. So I can give them butyrate all I want, but they're not going to produce their own butyrate. So going back to root cause is that I need to go back to the microbes which are not producing butyrate, replenish them with whatever we need to replenish them with, which we can go into detail here in a bit. Replenish them and making sure that we have enough of that so that they're creating enough butyrate for this person. So that if I need to put them on butyrate for an interim, for a short period of time, to be able to heal the gut lining, but I'm also helping with making sure that the microbes are being fed to produce butyrate, I can get them off butyrate and they continue to create the butyrate. So you're reteaching the gut how to be able to create this end products for themselves, right? So that gap is what I'm talking about. So let me give you another example of calprotectin. So calprotectin is usually a very good marker of showing me inflammation. Whenever calprotectin is high, I know that there's a lot of inflammation going on. So what do I need to do? I need to give anti-inflammatories. So we're talking about things like colostrum usually tends to help, curcumin tends to help, frankincense tends to help. But how long will I give them this anti-inflammatories? Because something like proteobacteria, for example, that usually is one of those bacteria which usually causes a lot of inflammation. So I need to go back to reduce the amount of proteobacteria so that they are not continuously producing a lot of inflammation. And thus, I'm going back to the root, and thus I'm giving them this curcumin. It's going to bring their inflammation down, but also reducing the proteobacteria makes them not produce more inflammation. So it's more of a permanent fix. And that is the key of missing. And the reason why that is the missing piece is because I have treated so many patients with protocols which I know work. They work, but after I recheck that test, probably about like a year later, it looks like they're inching back to where they started. And I'm like, this is not giving me the solution that I need. So this is where DeepGut comes in. And I've learned so much from the few meetings I've had with Dr. Ojobor and Linta. I've learned so much about these microbes that just taking that little practice that I've learned, I still have a lot to learn. But taking that little that I've gotten and applying it and starting to change the microbiome, it has made a huge difference in the people who have tried it on. Okay, so I would like to go into the tests that we did a test on one of my family members, which I would like to go into. Let me see how I can share this. Give me a minute. Is that sharing okay? It's good? Okay. All right. I'll be looking up, not on the camera, because I'm looking at the test. And it's my assumption that, Dr. Ojobor, you've gone through this test before to explain each and every individual component to it.
That's correct.
Okay, so what I'm going to do here is I'm going to be a little bit more general as opposed to being very specific to each marker, because I want to personalize it to this particular patient. Okay, so um, let's start with the gut health score. So the gut health score here, to me, I interpret it as how many of the things that we have tested at the bottom are in normal range, in optimal range. And 81 is actually not a very bad score. So there are some things that are still out of range that we will look at, and how can we be able to bring them back to range. Diversity score is telling me more of the richness and evenness. So are we having one bacteria being more prevalent than the other, and are they balanced? So are we getting a good balance of the microbiome? So I like the diversity score because I can correlate it to the taxonomy, which usually comes with the result, and you can be able to kind of scroll through and see how many microbes this person has. You can, I think this particular one was in the 200s, so somebody who has a higher diversity score, you'll probably see that number go further down. So, and correct me if I'm wrong, that's what I'm thinking, because I was comparing that with another patient who had a higher diversity score, and noticed theirs was way longer than this particular patient. Okay, let us start. So probiotics. So these are commensal bacteria. These are the good bacteria, as we call them. You want to have enough of them for sure, because they end up having an end product. And we'll talk about the end products because they're at the bottom of this report. So like Akkermansia is very good for the gut lining. It usually helps the mucosal layer of the gut lining. So you want to make sure that you have enough of it. And it's to my knowledge and my trending with checking Akkermansia for such a long time that it is always low. So there is a probiotic that has come up that you can be able to use. I think there's multiple ones. I usually use the pendulum one, but that's a good one to be able to use to bring Akkermansia up. Now, Akkermansia also needs a lot of polyphenols. It also needs fiber to be able to build it up. So like in this particular case, hers is really low, like it's at 0%. So I would want to colonize it a little bit. So I would give them the probiotic for a period of time while I'm also trying to feed it so it can keep itself up. Okay, bifidobacterium. So bifidobacterium here was low. Bifidobacterium is pretty foundational in my view. So it's a butyrate producer. It also helps with cognition. It also helps with insulin resistance. So it helps with quite a few things. So having enough bifidobacterium is really important. So most of the probiotics that I give, they would have a level of bifidobacterium in there. Now, Vitract has a list of probiotics which you can take, which usually have the specific strains that you need. And that can be provided. So, and then let's talk about Blautia. I may not pronounce these ones as good as Dr. Ojobor, though. So these ones are pretty high. And Blautia, to my knowledge, is usually more of an inflammatory type of bacteria, but also does play a role in breaking down sugar. So going back to the dig in, you're putting this in the category of inflammation. So the curcumins, the frankincense will help, but we need to be able to bring the Blautia down. So again, you're thinking about, okay, so what herbs can I be able to use, or what foods can I be able to use to be able to bring the Blautia number down? Okay. So, and that's kind of the thinking process you want to, you're not just focusing on the functionality and the end product, you're also focusing on the microbe, how you can feed it or how you can starve it, so that if it's overgrowing, you're starving it. If it's undergrowing, you're feeding it. This guy fascinates me, the Faecalibacterium. I can never say this last name right, but this one fascinates me because it engulfs acetate and it produces butyrate. So it's a crossfeeder, and it's really impressive to know that I can be able to feed it hydrogen, I can be able to feed it acetate, and it's going to come out to give me something good like butyrate. So whenever you're dealing with pathogen, let's give it, for example, E. coli. E. coli is a high hydrogen producer, or Klebsiella pneumonia is a high hydrogen producer. That hydrogen being produced can be engulfed by a Faecalibacterium, to produce butyrate. So that hydrogen is not going into a place to create like something like hydrogen sulfide or hydrogen dominant SIBO or methane dominant SIBO. Instead, the fecal bacterium is converting it into something good. So I really like it. So whenever you see this being low, you make it a priority to feed it so that you're not creating things like SIBO. Okay. Lactobacillus is another foundational one. Produces a lot of neurotransmitters. So in this particular case, it's optimal. It is on the lower side, but it's optimal. So again, that's one of those that I would say, you know what, I still want to give you a little bit of lactobacillus, but I don't want to give you too much of it because I don't want it to overgrow too. Rosbirya is another butyrate producer. So if it's a butyrate producer, it's probably going into the intestinal permeability in the dig-in mnemonic. It's under intestinal permeability, but it also does affect inflammation. So it would go into the inflammation category. So you want to bring this up. Resistant starch is usually pretty good. Rabinogalactans usually bring it up too. And then Raminococcus are both within optimal range here. We have a few optimals here. Okay, so anaerobic butyric, jeez, that's a long name. So this one, it's a gas producer. And so this would kind of feed to like the disolvable Vibrio, which we'll talk about here in a bit, and Bilophila, so hydrogen sulfide, or you can find methanobacteria, so methane gas. So you don't want overgrowth of this one. You want, because it's going to produce more gases, which can make you susceptible to getting SIBO. So again, going back to treating SIBO, this person, you find that whenever you check their test, they have SIBO. You treat SIBO, but you are not reducing the microbes which are causing that SIBO. It's going to reoccur. So again, going back to the microbiome and treating that usually is really important to have more permanent changes. Pancreatitis, both of them are optimal here. Okay, so Oxalobacter. So this one is one that usually breaks down oxalates. So you definitely want to feed this a little bit more. And oxalates usually tend to cause things like kidney stones. So it's calcium oxalate, which usually causes kidney stones. So you want to avoid that, especially if you have a patient who has kidney stones and then you find this is low, then high possibilities you want to feed this so that it can be breaking down the oxalate so that you don't have recurrence of kidney stones. Okay. Let's see here. E. coli is low. Klebsiella. Okay, so Klebsiella here is high. So Klebsiella is definitely a pathogen. So hydrogen producing, it also produces a lot of CO2, lactic acid. I think it also produces ethanol. So you definitely want to get rid of this guy as soon as you can. So this is one of those that you have to find really good herbs that you can be able to cycle. So if you're using something like berberine or oregano or neem to cycle them like every 2 weeks so that it doesn't build resistance, because Klebsiella sometimes can form some biofilms. And cycling it so you can be able to kill the Klebsiella so that it's not producing hydrogen, because that hydrogen can go ahead and start producing hydrogen sulfide here, like the Bilophila. It may not even be the overgrowth of Bilophila here per se. It might be the hydrogen from the Klebsiella that's feeding the Bilophila, and the Bilophila is overgrowing. So if you get rid of the Klebsiella, the Bilophila may come back down to normal range. The sulfur vibrio was optimal, Fusobacterium was optimal here. Proteobacteria, I talked about this, about inflammation. In this particular case, she doesn't have a lot of it, which is good. And then the methano, so whenever this is high, just telling you that they're producing a lot of methane gas, and it can also be they have SIBO, which is methane dominant. Okay, some of the pathogens here, the Staphylococcus aureus was detected here, but I believe that this is not high enough for me to say it's a problem, correct? Because I think it's 0 to 0.1, correct, Dr. Ojobor?
That's correct.
Okay. Gotcha. So this would not be something that I would be concerned with. Probably by the time I'm actually reviewing this test, they probably have cleared it out. Okay. All right. No fungus, which is good. So no candida, which candida is really stubborn, but there's none here. No viruses here, which is good. No protozoas here, which is great. And then no worms. So protozoas is what we call parasites, and also worms are parasites. But none of them were detected. And then the antimicrobial resistant genus just tells you if you're going to use antibiotics, pharmaceutical antibiotics, to be able to reduce some of the overgrowth of some of this bacteria, that if it's positive, then it's probably going to be resistant. So you want to use the ones that are negative. Okay, so this is like, we've taken all those levels of microbes up there, and we are translating that into the end product. So in this particular case, acetate, butyrate, and propionate, all of them are pretty low. So treatment would be, okay, I'm going to give you the butyrate, but let's work on the microbes up there to see how we can be able to increase this, guys. And same thing with the neurotransmitters, especially like for my wife, which this test is my wife's. I can tell that she usually has a hard time focusing. So giving her something like L-tyrosine with some B6 to help her focus, but working on the microbiome to make sure that we are creating enough dopamine for her. And the same thing with GABA. Yeah, histamine. I talked about histamine extensively before. So treating it now, but also working on the back end. Then vitamins here. So she does take a B complex just because I noticed her B's were low. So giving her the B complex, but that is just a temporary fix, going back and treating the microbiome so that you can create enough B vitamins. Okay, vitamin K. Okay, good. Ammonia. So ammonia was good, but ammonia is usually pretty high whenever somebody's on a high protein diet, because whenever you eat protein, it usually has to be broken down into the essential amino acids that you're getting from that food, and in that process of breaking down, it releases a lot of nitrogen. Nitrogen and hydrogen coming together usually forms ammonia. So that usually tends to cause a lot of brain fog, a lot of brain issues. So you always want to make sure that ammonia is low. So again, going back to how can we be able to move the microbiome around so you can have less ammonia production. And hydrogen sulfide, we saw the bilophila up there. Liposaccharides are low because the proteobacteria was low. Methanol and TMAO, again, another one from ammonia. And then beta glucuronidase. So this is an enzyme which reabsorbs toxins and excess hormones. So whenever it's low, I actually usually don't get too concerned about it. It's whenever it's high that I'm concerned, because it will reabsorb so many of those toxins, which can end up causing a lot of issues like estrogen dominance. So it goes hormonally and starts causing issues, or it starts causing methylation issues with your liver. So making sure the beta glucuronidase is low is good, but also making sure that the microbes which are producing beta glucuronidase are also eradicated, and you're feeding the good bacteria, which would starve the others. And then longevity markers like myrosinase, urolithin, again, going back to just what produces them and working through that. You can give people myrosinase, you can give urolithin A, but again, doing functional medicine for a long time, you find that a lot of patients will complain one way or the another that they have supplement overload. They're being that they are so paralyzed with just being overwhelmed with taking too many supplements. So if there is a chance of you going even further back to repair things so that they don't have to take the supplements like urolithin and myrosinase, the better, because the whole point is to you to get them back to balance where they can produce these things by themselves. And then this is just now going back to the dig in, going to the digestive part of it. It's showing you the microbes which help with digestion of different types of food. So carbohydrates, fats, lactose, oxalates. All this will look pretty satisfactory. And protein metabolizers, yes. All right, and then now we get into what would you do for this thing. So there's a lot of recommendations here for food and probiotics and supplements. So here, what you probably want to do is, because it can get overwhelming whenever you're looking at this, you're like, okay, what probiotic can I get all this all in one, right? Um, you definitely want to start simple. My foundation is always Lactobacillus and Bifidobacterium. That's a good place to start. And then you can tack in more things as you go. And replacing usually comes like later in the gut protocol anyways. You usually start with removal first. So you want to remove the pathogens or the pathobionts that are overgrowing, that you want to remove those first prior to you starting to replenish and replace the probiotics. So the killing will come first. So you will start with probably the herbs, like the ones that I named, like the berberine, the neem, the oregano, the thyme, the garlic, and seeing which one usually would work best for the pathobionts or the pathogens that you're dealing with. And then from there you get to the place of replacement. Eventually you can do some repair while you're doing the replacement. So you're repairing the gut lining with things like L-glutamine. You could do things like BPC 157, which is a peptide, or something like thymosin beta 4, or you could do glycine. So those ones usually tend to go in there and repair the gut lining while you're working on replenishing the probiotics. Now, after you get the foundations down, like Lactobacillus, Bifidobacterium, now you can go into a little bit more detail, the Akkermansias, and then you can go into the prebiotics and see, okay, so which prebiotics would help this particular like Faculobacterium, what would increase that, and you can give them that. So you kind of build up on the protocol so that you're not overwhelming the patient. That's number one. But number two, the patient is also not getting so many side effects from you giving them so many things all at once. So here, like they have betaine, so which will be HCl, which will go to digestion. EGCGs are polyphenol, so it will feed something like Akkermansia. Vitamin D, which I mean most people are low in that anyways. Okay, and then prebiotics as oligogalactans, the guar which is sun fiber, is a good source of that. And so all these ones are just feeding the good bacteria. And as scientists, I mean, there's the science bit of it, and then there's the practice bit of it. As a scientist, obviously, you want to also go deep a little bit and see, okay, so how can I increase rosburia? What's the most effective way of doing it without stressing my patient? So if I can be able to say, hey, look, eat some plantains, which would be green banana, that would help you get some resistant starch a little bit more compared to me giving you a supplement, then go for that. You know, whatever works for your patient. And lifestyle changes, which we already do anyways prior to even getting to the point of doing a stool test. Yeah, and then it has all the references there that you would need to look into. And I like this because I don't have to go to PubMed and search it. I could just like click it and it takes me there. So it saves me a lot of time. So, and then the other piece of this test that I didn't talk about is I'll stop sharing here, is the collection. So most of the time, whenever I give patients a stool test, there's usually an apprehension of, so I have to collect my own stool, and how much of it do I have to collect? And most of the time, it's usually you have these 3 containers, and you kind of have to fill them to a particular place. So there's a lot of stool that you have to pull. But with the Vitract tests, it's pretty easy. Whenever you wipe, you just take the swab that they have in the kit, and you just swab it on your toilet paper, and then you put it in the specimen cup that they have, and you roll it a few times, pull it out, and you seal it, and you send it. Like, it's so easy. my wife has done multiple stool tests, and she said this was the most pleasant one that she has done. So it's such an easy process. It's not stressful, just because the type of testing that they're doing doesn't require such a huge amount. So it's yeah, it's really easy. So I really, if I haven't said this already, I really like this test. And it's really helping my practice elevate. So I'm thinking more about root cause than I did before, which is what I want to do with my practice. Yeah.
Very much, Daniel. That was very, very, very insightful. Like it was so good listening to you from practitioner's perspective and how you generally think about root cause medicine and just taking things away from just band-aid treatment to really understanding how you can, promote this intestinal health over time, over a prolonged period of time. I think that that's actually really fascinating. And this is why I really advocate for a lot of practitioners also to just get acquainted with the literature and how this works, because that's how you literally kind of like dial back to saying, this is how this works. Mechanism of action just helps you to really feed those things. We do have some questions here, so I think we can just go through those. We have a question from Sonia here. I'm also happy to provide a scientist perspective to this. But the first question is, what if oxalobacter is high? I guess she's asking what you would do if oxalobacter levels are high. I can quickly speak to that from a scientist perspective, and before that now goes. Typically, what we have seen from the thousands of tests we've done is like it's really, really rare to see people with high oxalobacter levels. Typically, what we tend to see is like actually really low levels of oxalobacter. As you know, because they break down oxalates, that reduces the potential to develop kidney stones. But because I think generally, calcium oxalates also have a way of binding to oxalate. And so I think that's the only downside that I would see there, where that could impair calcium absorption somehow, so which contributes to bone health. But it is very difficult for oxalobacter also to be excessive in the gut, just because it is a very, very fastidious organism. That is, it requires like very selected kind of diet to really thrive. And so they're usually considered to be low abundance organisms in the gut ecosystem. So the downside to excessive levels, which is very, very rare, is that's how I think about it, that the potential to impair calcium absorption. But the upside to having sufficient optimal levels of oxalobacter would then be to enhance kidney health. Dan, if you have anything to add there. Okay.
So I would approach it as a practitioner. The answer to that question is that I do not know, right? But the way I would approach it is I would say, okay, so I need to find out what can be able to reduce this. So is there an herb which I can be able to use that would not affect so many of the other microbes, but would be able to take that particular oxalobacterium and reduce it? So an example would be oregano. Let's take, for example, that's what it is. I'm going to use that and see if that will bring it down.
Excellent. Yes. Okay. The next question we have there is, can SIBO be detected as well as Lyme? I see H. pylori is there, but is that a definitive test?
So SIBO is one of the best way to test for SIBO is obviously a breath test. This would be a guide to show you. So for example, if you see the hydrogen sulfide is high, or you're seeing the methane is high, it should click to you that, hey, look, maybe I should go further to test to see if SIBO is present. Now, with that said, if your patient is not presenting with symptoms, that's another thing that you have to consider. So if all those bacteria are high, but they're not presenting with SIBO symptoms, they may not really have SIBO. They may just have dysbiosis. So you just need to treat that. As it pertains to Lyme, that's pretty hard to tell from just a gut test. Lyme usually does sometimes decimate some good bacteria, but it's not very specific depending on which Lyme you're dealing with, because you can be dealing with Borrelia or Bartonella or Babesia, and each of them usually do something different. So it will be a little bit difficult to extrapolate that from this test.
Thank you very much. And to add to Daniel's point on SIBO, so typically SIBO is what happens in the upper bowel, right? And but with this test, we're showing you what happens in the lower bowel, which is the colon. SIBO tells you what happens in the small intestine. But like Daniel said, what's happening in the lower bowel can actually give you an insight into your SIBO breath test. So when you do a SIBO breath test and you get your result back, it kind of like gives you a sense of what's happening in the small intestine. But there are studies that have shown that some of the gases that actually show up on your SIBO breath test are coming from the byproduct of the bugs that are in your large intestine. So I don't know if some of you know, but the original purpose of the SIBO breath test was not to diagnose SIBO. It was to basically test transit time. All right. And
Mm.
because transit time is different from person to person, there's this fantastic study where they showed people from Asia having a different transit time from people in the West and all that. So if all of you do a civil test, your transit times, because they're different, whatever result you're getting, although it tells you what's happening in the small intestine, but a lot of the gases are also because of the bugs in the large intestine. So when you see an overgrowth in the in the large intestine based off of the microbiome test that Vitract offers, it can give you a sense, like Daniel said, as to what's happening up there. And in the case of H. pylori, you're asking if this is a definitive test. Yeah, so what we are offering here is a deep shotgun sequencing. That is to say that even if the levels of those bugs are super, super low, we're able to capture them. And this is one way that we actually differentiate from other shotgun tests, which are shallow. What we do is deep, can capture rare species and super low species as well. So if we find H. pylori in your sample, we're going to catch it and we're going to report it. Okay, the next question here is, are there markers that look at enzyme and bioproduction or steatocrit and SIG-A? You're muted, Daniel.
Um, in this test, it looks at it a little bit differently. I totally relate with the person who just asked that question. Because you're looking at a bit of a different angle. So whenever it comes to digestion, it's not just those things that you're talking about, the steatocrit, the elastase, which is another one that you may think about, that determine digestion. Those ones are the functional part of it. So we're looking at the pancreas and how it produces elastase, or whenever it comes to steatocrit, you're looking at the amount of fat that's in your stool to see if it's being broken down very well. Now, if you do not have fat metabolizers as it pertains to your microbiome, high possibilities that your steatocrit is going to be high. But the problem is you're probably going to be assuming that it's all bile issues, right? And then you're going to give something like ox bile or taurine to be able to help with breaking down the fat, but you're not getting the full picture. There might be something, the microbiome, that usually helps to break down the fat that you're not addressing, and you will see that steatocrit creep back up because you have not taken care of the root cause. Yeah.
Yeah, that's an excellent answer, Dan. Thanks for providing that perspective. Andrea is asking, she says, I may have missed it, but does this individual have a narrow diet or how to explain such low species diversity?
She doesn't have a narrow diet. I wouldn't say so. And maybe you would speak to this a little bit
Yeah.
more about what you usually see with the test the more you test it. But from the few that I've seen, I'm not seeing a lot of diversity. It's more of most people, even whenever people are eating a really good diet, I'm still not seeing a lot of diversity. Which tells me it may be cultural, it may be just our food industry that we need to kind of engage a little bit more into regenerative agriculture. I'm not sure.
Yes, absolutely. It's that we in North America, unfortunately, we have a very poisoned food system. There are interesting studies that have compared the gut profiles of people who do hunter-gatherer style of living in Tanzania, the Hadza group, and compare them to people who live in California. And you can clearly see diversity of like total number of species, about 700 species in the Tanzania group, and then in California the average is about 200. And so there's a lot of species extinction in North America, unsurprisingly. Also, the myriad of pesticides that our food is being sprayed with, all of those things impact our gut in remarkable ways, creating that chronic inflammation that depletes a lot of the beneficial species. But if I may speak a little bit more to how the diversity scores are calculated. So what we are comparing, that score that you see in the section one, we're comparing you to 1,071 healthy individuals. And when we say healthy here, we just mean these individuals have reported that they don't have symptoms and they have not been diagnosed with any condition. And so we are basically comparing you to them, to all their diversity scores. So that is when we look at the total number of species you have and we compare it to them, we tell you the percentile range that you fall under. So for the report that Daniel showed, she had, I think her score was 20. It means that she actually sits in the 20th percentile. That is, she has diversity score more than 20% of those healthy people. So it's I was actually talking to someone about it. I'm like, I think it's a little bit unfair to say that if you get 50, for example, you're in the median of these healthy people. We don't say you're healthy. So however, deep gut is different from gut scan. Now, for gut scan, the way we calculate the diversity is we're comparing it to everybody who has taken the test. So gut scan is our first test. We're comparing to everybody who have taken the test. So a lot of people who are taking this test have some condition or the other. And so they're coming to take the test. So you might actually take a gut scan and your diversity score is higher. But if you take a deep gut, we are actually comparing you to the healthy population, which I believe should be the standard you should be looking at there. And I think this answers another person's question. I think Julie's question down the line. So we'll just skip that other question. The other question here is the smaller amount of stool collection just as effective as the larger amount? I can speak to this from the technology perspective, the diagnostic perspective, and Dan, you've done other tests where they're collecting large amounts of stool. You can also speak, give a practitioner perspective to this. So one of the main reasons why they collect a lot of stool for many of the legacy tests that you guys do is because there are different protocols that are applied to the different portions of the stool. In fact, for a lot of people, they even make you collect stool in different vials. So let's take one of these legacy tests, for example. Apart from the PCR they do, for some of them, they still do stool culturing, which is pretty much just plating your stool on a plate and putting it in the incubator. I did that like 15 years ago when I started microbiology. I don't know why anyone does that now. But I see why, I do understand why they do that, but in the context of the gut microbiome, it really doesn't tell you anything, except for maybe when you're trying to do sensitivity test. But thirdly, some of the stool that they collect actually go to chemistry labs where they have to do things like mass spec on them. So it is because that sample you're giving has to go through different techniques and protocols, so that you have to got a large amount of stool. But for us, we're using the next generation sequencing technology. Next generation because it's a very very powerful technology that is able to give you an insight into your gut profile just with a sample, the strand of the size of rice. Okay, so it depends on the technique. Some techniques require larger samples. Our technique does not, and that's why. Okay, so that's from a diagnostic perspective. I think that's actually a really, really good question. One thing you didn't ask here that I can quickly speak to is that a lot of people have issues with like collection as well. Like we've done that internal experiment where you collect your sample, you're like, do I take it from one spot? Do I take it from several spots? From our in-house analysis with our own technique, we've seen that there is actually no significant difference in taking from one spot versus taking from other spot. But I usually encourage that you take from different spots just so you can try to get like a pretty much like a rounded sense of what's happening there. I'm done now.
Yeah, I mean, I think you answered it. I think it's more obviously to the diagnostic side. I have not like the inco for my patients it'd probably be an inconvenience and a convenience issue as opposed to it being an amount issue. So sitting there and having to collect for 10, 15 minutes as opposed to just swabbing for 30 seconds, So that will be the big difference, yeah.
Would this be applicable for pediatrics, specifically toddlers? Well, the ranges that we give there, they're for adults. So the healthy group that we're comparing you against have to be at least the age of 12. However, you can do this test. You can do this test on children, but you are not going to be using the same ranges for them. Okay. So remember, when you do this test, we have two files that we give you, three files. One is the report, another is the taxonomy file, which is where we show everything. In children, for example, gut diversity usually is low because when you're a child and say that you're being breastfed, I actually did this on my son when we just gave it to him. You try this out at age 1 or like a couple of months, you see bifidobacterium can make up to 80%. Okay, if you put that on our scale here, that would be too high. But that's actually normal for children. So you have to remember age impacts the gut microbiome. It's like ecological succession. What you see in the forest, there are primary successors, there are secondary successors, and there are tertiary successors. And that continues to be impacted by several other things, disease and environment and sleep and every other thing like that. So yeah, the test is absolutely spot on for children, but you cannot just use the same ranges. Is the amount of stool needed greater than the amount for gut scan? Is the amount of stool needed for deep gut tests greater than the amount needed for gut scan? No, it's the same amount. If a client does deep gut test and then we test using gut scan, is it comparing apples to apples if you consider sections 1 and 2? That's a good question. I think I answered one part of it with the diversity. The other part of it here is, so if you look at your gut scan, you would notice that the organisms that we stated in the section 2 are organisms, we define them at the genus level. So what I mean by genus level is when you're defining bacteria or any organism, you define them according to their generation, just like you have a great grandparents, grandparents, parents, children. We at the genus level is parent, then children is species level. With DeepGut, we define both at the parent level and at the child level. And that's just because, of course, you and your sibling might be offsprings of your parents, but you still have some differences. So DeepGut has more resolution. We go down to, children, and even like if a child can actually have a child, that strain, we also go down to that. So the resolution for DeepGut is higher than that of GutScan. However, with GutScan, you can still get that good sense of gut dysbiosis. It's just that you have better resolution with DeepGut. Daniel, this question is for you. What kind of success have you seen after making adjustments in the way you explain that you do? How long does it normally take on average? What has been the most difficult case or type of imbalance shift, if there is any?
Big difference that I've seen is that I'm seeing more of a permanent change, as opposed to I was used to just doing like a 6-week gut protocol where we eliminate inflammatory foods and then I give you the supplements that you need to be able to rectify things that I was seeing in the gut test. And after the 6 weeks, what usually ends up happening is that the patient is so tired of eating the limited diet that we have put them on, and they start reintroducing foods and they don't feel good when they do that, right? The big thing that I changed here, obviously, is working on the patient on mindset, and then 2, helping them know that, hey, look, this is a permanent fix that we're going for. We're just not doing a protocol. And that by doing so, keeping them on a little bit more probiotics and prebiotic fibers, and which I have been using prebiotic fibers a lot more than I was before. And by doing so, I'm noticing that even whenever they start reintroducing foods, however drastic they choose to go, they're not getting as much symptoms as they did before. And they are finding a little bit more resilience in terms of whenever they're introducing foods, and even whenever they're eating foods which are really out there. We're talking about gluten and dairy and soy, which are really inflammatory. They're noticing that they have a little bit more resilience in that they can be able to tolerate them more. So that's probably the biggest difference I've noticed. What was the second part of the question? Let me see.
Yeah, the second part of the question is what have been the most difficult type of imbalance that you've seen?
Um, Most difficult will probably be hydrogen sulfide. Um, Hydrogen sulfide and methane. Those are pretty difficult to get rid of, especially whenever they're really high. There's a lot of killing that has to happen, and sometimes you actually have to use pharmaceuticals for them. Now, it doesn't necessarily mean that they have SIBO. It just means that they have overgrowth of those, and those bacteria are just a little bit stubborn to kill. Um, and then obviously when it comes to fungus, that's also pretty, it's a pretty hard protocol to do just because it's the length of time is pretty long because fungus usually takes time to be eradicated.
Absolutely. Thank you. And this question also is for you, Daniel. Does everyone have some H. pylori? Would you recommend treating only if there are symptoms?
That's a very good question. I have seen so much H. pylori in my last, honestly, since COVID. I've seen a lot more H. pylori. And maybe the test that I'm using at this particular time is very sensitive. But I usually don't treat everyone. I treat people who are symptomatic and the symptoms are aligning with the H. pylori. I guess that's the best way to put it. Because you can have gut issues, but it's not symptoms of H. pylori because that's usually mostly in your stomach, right? So I tend not to treat, although I usually do sometimes. Just if I see the H. pylori is really high, I would give something like mastic gum, which would be a mild treatment to see if it would help with any of their symptoms. And most of the time, it usually does. But most of the time, honestly, in the context of things, out of 10 patients who I find H. pylori to be positive, I will probably treat maybe one. Yeah.
Makes a lot of sense. I used to say that back in Nigeria, almost over 45% of the population actually has H. pylori. It's a commensal. It stays there. For some people, it ends up causing peptic ulcer. But more often than not, when people just rebalance like stomach acid and take care of like what's happening, they're fine.
Correct.
And then the other question here is when is deep gut recommended over regular test? I guess regular test is I don't know if what Michelle means here as regular test is gut scan or other tests. So Daniel, like I'm really curious to know from a practitioner perspective, you've seen both tests.
Yeah.
When would you order a deep gut versus a gut scan?
I would order a deep gut whenever I'm seeing a new patient. Anytime I'm seeing somebody who's having any gut issue, well, I order a stool test for every patient, anyways. But um, at the beginning of our relationship with the patient, I will be ordering a deep gut. Now, from there, if I want to repeat things and I want to see how things are going, we could move to the gut scan, depending on what's showing up, of course. If fungus is showing up, high possibilities I will repeat the deep gut again, just because those markers are not in the gut scan. Yeah.
Yeah, absolutely. Um, to add to that, if you are suspecting that the dysbiosis could be caused by other microbes other than bacteria, that is maybe it's a fungi, it's a virus, or it's a protozoa, then it makes sense to do a deep gut because a gut scan is not going to capture that. If you're also interested in things like antimicrobial resistance genes, then yes, it makes sense to do a deep gut because gut scan also does not capture that. If you're also somebody who just wants to get into the nitty gritty of like the strain level information, species level information, then yes, it makes sense to do a deep gut. Okay, it looks like that's it. There's a lot of brilliant questions and a lot of engagement. Daniel, I can't thank you enough. I think that this was remarkable, and I think that you've kind of like given us a sense, and you've given us, you've allowed us see through your lenses as a practitioner, and that's fascinating. Not just for the attendees, actually, for also people like myself and Linta, because we're always trying to build things for the practitioner. So it's really good to know how you guys use them. I want to thank you very much. For the rest of the people who also joined, I want to thank you for being part of this. This was really, really enjoyable. We want to let you know that we're going to be doing this every month. We're going to be bringing different practitioners, and so always make sure that you sign up. And different practitioners are going to bring different perspectives to this. And then, yes, the recording will be sent out. Daniel, thank you very much for your time, and goodbye, everyone.